Hello, 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 everybody. Let's get rid of the core dump. Let's get rid of this. So, let's start off by saying I got the binary parser working. Which is pretty dope. So if you've been around for day 16, you saw me write a string-based parser for the packets problem with the operators and the literal packets and stuff like that. And so I switched that to a fully binary parser. So I talked a little bit about this yesterday, but I've got the full thing working now. All of the tests pass, and we have dropped from almost a third of heap allocation. So from 65 total down to 20, and from 22 to 14 or 15 at Gmax, which is really cool. But the most interesting thing I think about switching to the binary parser is that it brought our runtime down from 340 microseconds, or like 350 microseconds, down to 100 or down to 95. So that was really interesting, because like it took a little bit of work, but it all works now, and that's wonderful. And if I wanted to, I could stack errors on top of it, and we would have a super fast binary parser with diagnostics, which is kind of cool. So today's day 18 though, which means we have to CPR day 17, day 18. Also, hello, Commander. Good to see you. Thanks for coming back, hanging out. Day 18, code, and then let's take a look at, do I have it open? Let's make this smaller. Oh, if you're interested in the PR for the binary parser and what changed, we have a PR up on the Advent of Code repo. So Christopher Riscardi, Advent of Code, pull request number 1 is all of the changes I made and all of the commits that led to those changes for the binary parser. So if you're interested, go check that out. Calendar 18. Let's get rid of all of these. Snailfish. And now, not a binary parser, but a binary tree parser. Okay, interesting. Is that what's happening today? You descend into the open trench and encounter some snailfish. What's a snailfish? It's gonna be Wikipedia. Why is it called a snailfish? Apparently they saw this Lake Keys. And they'll tell me if they help me with if I help one of the smaller snailfish with his homework. Okay. I didn't even do my homework. Snailfish numbers aren't like regular numbers. Instead, every snailfish number is a pair, an ordered list of 2 elements. So a tuple. Each element of the pair can either be a regular number or another pair. Pairs are written as XY, where X and Y are the elements within the pair. Here are some examples. Snailfish numbers with one number per line. So yeah, basically like what Commander just said, we have a tree. At the basic level, we just have 2 numbers. At the 3 number level, we can have either a snailfish number with 2 numbers inside it, or just a number on either side. And that continues throughout until we get to all of the leaves of the tree. So this snailfish homework is about addition. To add 2 snailfish numbers from a pair from the left to right. Form a pair from the left and right parameters of the addition operator. For example, 1, 2 plus 3, 4, and 5 becomes a snailfish number where the left is 1, 2, and the right is 3, 4, and 5. That seems pretty simple. We just create another tuple. There's only one problem. Snailfish numbers must always be reduced. And the process of adding two snailfish numbers can result in snailfish numbers that need to be reduced. To reduce a snailfish number, you must repeatedly do the first action in this list that applies to the snailfish number. If any pair is nested inside 4 pairs, the leftmost such pair explodes. If any regular number is 10 or greater, then the leftmost such regular number splits. Splits into what? Once no action in the above list applies, snailfish number is reduced. During reduction, at most one action applies, after which the process returns to the top of the list of the actions. For example, if a split produces a pair that meets the explode criteria, that pair explodes before other splits occur. Interesting. So is that saying that that is the only snailfish pair that meets the explode criteria? I guess that would be, right? Because otherwise something else would have exploded first. To explode a pair, the pair's left value is added to the first regular number to the left, if any, and the pair's right value is added to the first regular number to the right, if any. Exploding pairs will always consist of 2 regular numbers. Then the entire exploding pair is replaced with the regular number 0. So we're treating these as being like the children are what they're saying is next to, right? 10 to 5, 5, 11 to 5, 6. But which side do you put the 6 on? Okay, so we have a snail number here, which is what, 9, 8, and 1, and 2, and 3, and 4. So this is just 9, 8 at the bottom, left-hand side bottom of a tree. And then that becomes exploded, which means we go to the parent, it looks like. Yeah. So we go up a level, which is interesting. And then we add what, 8 and 1 together? And we add 9 and nothing, so it becomes nothing. Okay. And then I guess let's start with doing that, and then we will move into these other examples. I think I have enough to start writing this. Let's go with lib.rs. Let's get rid of arc stuff, all of the stuff from yesterday. I've realized that these are smaller than usual. I will blow them up in a second. Get rid of all this stuff. Return 0. Get rid of all this stuff. Return 0. Get rid of all of our tests from yesterday. Actually, don't get rid of our tests from yesterday. Just comment these out for now, because they're not the tests that we care about. All right. A split of snailfish, if odd, the right one becomes the higher value. Write a parser for a binary tree in nom. Yeah, I mean, that sounds right. That's exactly what I'm planning on doing. This needs to be okay, input 0. Okay, so I'm going to go with struct snailfish, I think. And left is going to be let's see. Left is either going to be a snailfish or a number, right? So how do we want to do this? Enum, snailfish, probably. And the enum is either a number, which we'll call like a U32 or something, or it's or it's a snailfish. How am I going to represent this? Binary tree. My brain is not working. Okay, so we have the snailfish with left and right. Left and right can both be enums. Which means that they can be either number or fish number. In the case of fish number, we call it fish, and I guess we just store these in tuples. I don't really want to store them in tuples, though. Why are these complaining? Cargo test. Recursive type has infinite size. Of course it does. Theoretically does, anyway. We could box the fishes. We could go with tuples here. I think I'm going to go with tuples. I think this gives us the same issue, though. Yeah. Recursive type has infinite size because it just keeps going. These kind of need to be references, but I guess let's write it with tuples first, and then we'll move back to doing structs later, because it doesn't really matter for us. So for puzzle input, we're going to get what? A list of numbers. Let's go look at the puzzle input. Yeah, giant list of numbers. So let's do puzzle input, function, snailfish, input, string slice, I result, string slice, usize. And then this is just going to be separated pair by comma. This is complete U32. This is tag, comma. This is complete U32. Input, question mark. So let input fish equals this, but this really needs to be snailfish again, right? Except for the fact that snailfish needs to detect whether this separated pair is going to be a number or a fish. So maybe we do a branch here. If it's this is going to return a tuple. Let's do usize for the minute. Let's say it's input 0 for now. Input num complete U32. This could fail. Right? We just need to keep parsing snailfish as long as we can. So maybe we match snailfish, right? Let's do let that has snailfish equals snailfish input. Match has snailfish with OK, which is input fish, or error, which we don't care about. And this is where we do the number parsing. So this is where we can do this. Because if the snailfish doesn't exist, then it has to be a number. And here we can do input fish equals snailfish. An enum variant can also have name fields like a struct. You are absolutely correct. I don't know why I didn't remember that. We've literally done that this week. Hey, Nikki, how's it going? Okay, so we have these. If we run snailfish on input, we have snailfish, which runs snailfish on input. Let's do this instead. Let's not do the full snailfish. Let's do tag open paren or open bracket. Or is tag in bits up here? Bytes complete tag. No, we should be good. Why is this complaining? Is that because we don't have this here? Yeah, I guess so. We don't want it to be that though. That's gonna be annoying. So let's do this. Let's pull in a type here. This is gonna be iResult, whatever, whatever. We might want to bring in the error tree type just to have an error. I think the issue is that it can't infer the error because we're not going through the iResult return type. Expected use size found string slice. This is going to be string slice. Then we match on this. If we have the open bracket, then we try to parse another snailfish. If we don't, then we have this. And at the end of all of it, we still need to parse a closing bracket. So maybe what do we return from match? Let tuple equals this, maybe. And then this is, let's do input fish tuple. This is going to be input fish tuple. And this is going to be input fish tuple. And this is going to be let input and throwaway equals tag with the closing because they all close on the input. What's the problem with the input and the fish types? Expected use size found tuple. Right, because what? Bring Rust Analyzer use sizes back in. Fish tuple is a use size here. That's because snailfish returns a use size. This needs to return a tuple. That actually doesn't work, does it? The recursive tuple here. We actually do need to do the struct. Missed start. How did you decide to parse this? I was going to parse it as a tree, basically, because that's what Commander wanted to see. But my brain isn't working this morning. Recursive types do need to be kind of boxed. So maybe I go back to that, right? If we have a snailfish and it's an enum, it could either be a number with a U32 or a fish, which is a snailfish, right? But the snailfish needs to be boxed because if we don't box it, then it'll overflow or whatever. It can't be, we can't have these infinitely recursive on the stack like a linked list. Is that the answer there? And this is just going to be snailfish then. Which means that at some point we have to do numbers. We do numbers here. We do fish. Actually, yeah, that goes all the way down. So this is a snailfish. Fish that is a number, right? Fish.0 and a snailfish number, fish.1, right? I guess technically these could be anything, right? So they have to be potentially snailfish as well. My brain is not doing this well. So the parser that we actually have to write is just for whether there's an open bracket or a number. If there is a number, then we parse it, and then we continue with the right-hand side. If there's an open bracket, then we continue with a number. Dang, I really didn't think that the boosters was gonna mess with me this much. So basically, when we start parsing snailfish, we have to test to see if there's a open square bracket, because that indicates that there is a sub snailfish that we need to enter into. You think fish needs left and right? I think you're right. This isn't how we parse left and right, which is the problem I was thinking of, I guess. Because this doesn't, just because there's a number doesn't mean there is also a number. So I have to fix that, but I will worry about that in a second. Yes, because the packets were in Vex. Because Vex store their data on the heap, and these are not guaranteed to store their data on the heap, basically. Like a Vec is, if you look at the internal structure of a Vec, it's something like a pointer to where the data lives on the heap, kind of thing. So, brief overview of stack versus heap, because probably not everybody in chat knows that. When we run a function, all of the variables that we declare have some amount of space that they need. All of the arguments that come into our function have some space that they need. And the space that we allocate there is, we'll say, put into the stack. So we get a frame, basically, right? The function that we call needs some amount of space to declare the arguments that we get, as well as the variables we declare in the space that they need, right? That amount of space needs to be deterministic, right? We need to take that and we need to put it in with the rest of the stack as a single frame, and there's some amount of space, and all of the arguments, all of the variables, all of that kind of stuff fits in that space. So every time you call a function, we put a frame onto the stack, and that space needs to be there. If we do it like this, that space is not sized, is the way that we think about it. We have, if we do it without the boxes, that is, because then the argument could be, or the variable could be an infinitely growing snailfish, basically, right? So the other thing that would work with that in mind would be something like this, which I am not going to do actually, but I just want to point out that this should also work. Right? So if we put two snailfish in a Vec, we wouldn't have to handle box ourselves, because box basically takes it out and moves it over to the other side. Yes, okay, fish. If there's a fish, there's things. If there's a number, it's just a U32. This needs to be, these need to be snailfish parsers. right? So I think actually we don't need to... You probably could also use just one box for both snailfish, left, right. Not sure if that's better though. Oh, for the tuple? Yeah, I don't know. In my head, I was thinking that I would box this and then I would box this because they're both kind of infinitely growing or whatever. So I don't know the difference between those two approaches actually. Between boxing the tuple and boxing each individual snailfish. Okay, so we've got a separated pair of snailfish. Each of snailfish always checks for open bracket. If it's an open bracket, or not an open bracket, open square bracket, then we have to parse another snailfish, right? So here we do okay, and this comes up to here. Has snailfish. We don't need this because that's just the bracket. Input fish equals separated pair snailfish snailfish, which will either be a number, comma, a number, or a snailfish, comma, a number, or something like that. These now need to be boxed, which I think is the problem. Box syntax, the exclamation point isn't stabilized yet, so we're gonna have to do this manually, or we're gonna have to pull that in. Expected enum snailfish found integer. What did I do wrong? Oh, right. I don't need to wrap these anymore. So like this. But this fish on the outside, I think, is still going to be boxed. Expected tuple found unit. Okay, so here, if we have an error, then we need to parse out a number, right? So if we didn't get the open square bracket, then we have to parse a number and a comma, right? And if we get a number, we have an optional comma, I think. Why did I type okay here? That's so weird. Input underscore equals tag or opt tag comma. So this optionally pulls out the comma because it could be the first number, it could be the second number, but if the comma is there, then we need to get rid of it because we're already handling that case here. So if we don't have an open bracket, then we try to parse a number, and a number is not going to be an open bracket. So we should be good there. And then do we parse a snailfish here? Let's see. I think we're already parsing the snailfish, right? So this is going to be input num, but it's going to be snailfish number num. Oh, I'm looking at the wrong error. We are down to the box errors. Okay, cool. So box, I guess we could do box around the tuple. Why did I capitalize N there? That's weird. Okay, and at the end, what we get out is a snailfish, right? Call this fish number. You know, you have good days and you have bad days, and I think today is is just a bad day. Okay, so let's write a test. Let's try to parse out some of these actual test parse. I don't know. Is a bracket even a valid? All of these have to parse, so we can write a test for each of them. What isn't stabilized yet? Okay, so there is you know how we did box new when we created the box? Like here, box new. Box syntax Rust. See if I can find it. Box syntax Rust unstable book. Currently, the only stable way to create a box is via the box new method. Also, it is not possible in stable Rust to destructure a box. Let's make this smaller, actually. This seems like a good thing to make into a clip and share with people. Okay, so right here, we're using box new. Box new we are using because this enum without these boxes would be unsized on the stack. So we're using box to put snailfish onto the heap. The box new method is what we were using to create the box around our value. There is something called box syntax that is in unstable Rust that you can enable, thus not stabilized yet. You enable it with a feature flag, and it allows you to write box and then the value instead of box new. There's also box patterns, which lets you match on boxes, which we may or may not enable. But I think it's still just the little syntactic sugar here. So that's what I was saying isn't stable yet. It's that box syntax. Okay, let's do snailfish. I'm just gonna start calling these like A, B, C, D, I think. Assert equals. We didn't derive equals for snailfish. So we should do that because we're going to need to. Should we play with unstable features today, or should we just stick with stable? Okay, snailfish. And actually, the other thing that I'm going to do here is, because we're doing this over and over and over, and I don't want to keep writing it, I'm going to use snailfish star. So by using snailfish star, what I get to do now, because snailfish number, as we see down here, snailfish fish, I get to remove that because it's a module path. I don't think I'm going to remove that one because, well, yeah, I'll remove that one. But we get to remove the module path because we brought basically the variance into scope. So down here, when I'm writing my test, now I get to write fish box new number 1, box new number 2, and this is going to be snail, lowercase fish this, and do let input fish equals snail fish, and then we're just going to pull this in right here, drop it right there, unwrap because we want this to always succeed. You can also return results from tests, which may be a better option. Okay, so now we need to implement debug, derive debug, equality, and partial equality. Could not compile, expected 1 argument, supplied 2. So I nested these boxes down here, which is my own fault. These are in a tuple. And now we failed on tag, basically. So at least we have a failing test case. So the input to bracket tag here, separated pair. This doesn't actually need to be a separated pair, does it? Now that I think about it. So we hit this, we hit this. I guess it does, right? There's a snailfish, comma, a snailfish. And then which tag though? So maybe we stick error tree in here and get some better error messages. Maybe today's a good day to do error message stuff. That would be interesting. It might get a little complicated though with all the boxing and whatnot. Let's do this instead. Let's do the cheap way. And let's do... Oh, you know what else I could do, actually, now that I think about it? I could drop this into the debugger and show you how to use that. That would be fun, too. Input error. So we're expecting a number. And then optional tag. Why is optional tag failing? That's what that says, right? We've got input. We go to error. Let's do input here. And let's do input here. So we're looking at error, input 1, 2. Error 2, input is 2. And then it's saying that this is failing? That doesn't feel right. That's not failing. Oh, this is failing. Because it's not necessarily... Why is that failing? We get to the end. We hit this. Do we get past this? We get past it. We return. Okay, interesting. And then what do? We start with... We need to test for more, I guess. This doesn't end necessarily. input fish number. So this should end and this should return, right? Let's do the debugger for a second. Let's do the thing. Let's do breakpoint here. Let's do breakpoint here. Let's do breakpoint here. Let's do breakpoint here. And let's do generate launch configurations from cargo.toml. So this is code LLDB. I need to take this and save it as launch.json. And day 18, right? Day 18, yeah, save. Launch.json already exists. Replace. That's because I copied it over from the other one. I actually didn't need to do that. So now down in our test, we have this debug here, and I will click it. And now we're in a debugger. So in our debugger, my head might be over this. Yeah, my head is over this. How do I change that? I don't think... Is that little collapse all... Let me turn my face off on the thing for a second, so I can show this. Okay, so while we're debugging, face cam off. On the top right, you can now see input 1, 2. That is the variable input right here in the function argument. That's the value that it has at the moment. So if we can either step forward or we can continue to the next breakpoint. I think I'm going to continue because we're just going to go into... So we've matched an open square bracket. Right? So basically we're stepping through the program slowly as we execute the test. So we're in the snailfish function. We've got the argument that we passed in from the test, which apparently comes in a giant overlay. We make it into the match, the OK version of the match, right? Because has snailfish over here, we'll make this a little bigger, has snailfish on the right over here. It has a value of OK 1, 2, close square bracket, and returned the open square bracket, right? So we can continue, and we get back to snailfish again. So we went through the first one, and then I assume that we hit this first snailfish. It hits our snailfish up here, and we're left with 1, 2 close. So as we step through this, we should hit the second one. So we are in the second one. We didn't have an open square bracket, right? See, our input over here is still 1, 2 because we didn't parse anything else yet. And now I'm just going to step through this and we're going to watch what happens. A couple of temporary things. This is all the debug stuff happening. We're now at the complete. So now we parsed 1 out. We've seen 1 here, 2, close square, which works. Then here, we do the same thing. The input is now 2 with a square close bracket. And I'm just stepping through this. Num is 1 here. So we return 1 with number, which brings us back to the output of this match function. So it brings us back to the top of the function. And has snailfish was an error. Interestingly. So if we return input here, we should get input and the fish number here. We do get 2 close bracket, and this is 1. So then we step through this again and we make it to tag. But input is 1, 2? No, input is 2 square bracket. So because we are shadowing here, the debugger shows us all of the inputs that we've declared. In this case, the first one was 1, 2 close before we did the parsing for the first number. And now we have another input that is 2 close square bracket. So we step through. We return. And now we're going to go into, and then it crashes. No, then it goes into other stuff. Let's keep going. And then we're done. So we do return the right thing from here. We get a fish number out of it. But we still have more input, right? We still have to parse the 2. So I think here we need to do the snailfish. That's the problem. We aren't parsing the second snailfish number, whether it's a number or... So let's get rid of these debugs. And up top, we're doing both of them. So down here, we need to potentially do both of them, I think. So here we have the input fish equals snailfish on the input, right? And this needs to be optional, I think, because we're going to pass it through again. So then we've got an optional fish here. So match on fish. This will either be some or none. If it's none, then this is a single number. If it's some, then it's a fish with a number num and a fish, right? Whereas the opt and num, opt is in combinators, I believe. Combinator opt. Opt is optional. So we could optionally parse a snailfish, but we won't get an error back out the top of our parser if we fail a snailfish here. So this is box new because we're doing a fish, and this is box new because we're doing a fish. Or maybe I just got that wrong. No, it's a tuple. Okay, we are still failing on tag. So let's do numfish. Fish is 2 here. Num is 1, so we get num and 2. We return the fish. that actually ate the ending. So we go in, we test this open bracket. We get one. So we go here into input, right? Input tries to parse to snailfish with the comma in between, but I'm not sure that it should. Should this be... Because why? Because we parse the first snailfish, which should just be a number, I think. So this snailfish would come back as a single number. Then we would leave the comma. Then the next one would come back as a number. So maybe we do this instead. We do complete. We're either parsing a number or we're not parsing anything. Right? So in this case, we hit input. We try to parse a snailfish. We don't have the open bracket. So we go to parse the number. We parse the number. We return the number. This only happens in the other one. So this doesn't happen here anymore. This happens here, because it's the only place that we close. And now our test pass. So a little confusing, little fuzzy today on everything. But basically what we're doing here is we have a snailfish, right? And where's our other debug? There's our debug. So we have a snailfish. Snailfish can either be number or fish. If it's a fish, it has snailfish contained. If it's a number, then it's just a number. What is with nested brackets? I'm not sure what you're asking, Commander. So snailfish returns the snailfish. If we have the snailfish, because I don't think we can get rid of this type annotation. Yes. So this type annotation is here to determine the error type of tag, because otherwise it's not getting the inference from the return of the function, because we're not actually returning it. You'll notice that we didn't use the question mark here because we want to match on that value in has snailfish. So we use has snailfish. Let me put a little bit of space between those. We use has snailfish, and if it's an okay value, then we throw away the open bracket and we parse a snailfish pair. Otherwise, if we don't have the open bracket, then we're supposed to be parsing a number, and it's either the first number or the second number. It doesn't matter. And if we get a number here, then we get a comma, then we get another number, and then we close it out. So that works for this one. That works for this one. Let me expand this and see if we can get a couple of the others in here. So write another test. This is going to be fish 3. This is going to be fish 1, 2. This is going to be test B. What did I do wrong there? Box, fish. Fish is a tuple. Oh, I didn't box it. Just a bajillion boxes for everybody. This is one of the reasons the new box syntax is going to be a little bit nicer. So that also works. So let's just jump directly to the most complicated example here. And we'll get our final test in. This. See, that would have been A, B, C, D, E, F. Let's hope that's not a predictor of something. So this is going to be awkward a little bit. So let's just run the test instead. And then we'll check the output. Test parse snailfish B redefined here. Snailfish B. Did I not? I didn't save the file. Saving the file is really important before you run your tests, y'all. So this is what we get out of that test. We do need to box all these fish. Which is going to be a little annoying, but we're going to do it. Let's do this. Let's do box, new, open. And then anywhere there is a closed fish, we need to close, 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 and close. And I wrote it wrong, didn't I? Very appropriate Christmas. All the red. The red and green and whatever Christmas tree. You know, I did that wrong, didn't I? Oh, that's kind of annoying. This fish is not boxed. The interior fishes are all boxed. But so are the numbers. A lot of box. Holy crap, this is rough to read. Maybe we do enable it just for the tests. What? A fish is a tuple of two boxes of two boxes. These also have to box. Fish, box new, right? What did I do wrong? 141. Yikes, finding syntax error in this is not fun. Okay. Test fish and let test fish equals this monstrosity, this absolute just... Okay, so now we can actually find a reasonable place for the error to have occurred. That seems like a weird place for that one to be. Does that mean we need this? Yes. So many boxes. This is why I didn't do all of them. Fish. Box new fish. Okay, that's our fish structure. Welcome to the boxed fish, boxed like fish. One, two, three, four. 1, 2, 3, 4. Okay, so these are 4 deep. And now we actually have to work on the problem. Now that we have the parsing done. Snailfish homework is about addition. To add 2 snailfish numbers, form a pair from the left and right parameters of the addition operator. For example, that and that equals snailfish. Lanterns, fish, drake. No? Lanterns, fish, drake. Lanterns, fish, drake. Oh, drake, no, drake, yes. Okay, yeah. Gotcha. Okay, so... we could impl add, I think, for this. I think I'm just going to start with a function. Well, actually, let's go take a look. Impl add. Standard ops add. Trait add. Output add. Self right hand side output. So let's take a look at this. And this is literally what I do for the basic traits. If I want to do something like impl add for snailfish, I'll just copy it and I'll change it. I did impl add. It's so clean in your solution then. Nice. So this is... if we have a left snailfish and a right snailfish, the basic version of this is add them into another snailfish. So we have snailfish, fish, right? And this needs to be a tuple. So that's our impl. So for snailfish, we should go be able to do a test now. Let's test add, right? Test add basic. And we'll do, what was it? 1, 2, and 3, 4, 5. Is that what we have here? Let's do 3, 4, 5. And this is 1, 2. A, B, A bish, A bish. And this is going to be one, two here. Fish 1, 2, and new. I already had it, didn't I? Get rid of this box, new, like that. And it should be that. And A plus B. And we cargo test. And what we end up with is I either set up the test wrong or it's actually incorrect. I didn't change the numbers is what happened. 3, 4, 5. So there's our snailfish. We have addition on snailfish. Snailfish. So this is our test. This is what it looks like to add two snailfish together now. Deploying without first testing, you do this, yellow. Okay, so we need to reduce them when we add them. To reduce a snailfish number, you must repeatedly do the first action in this list that applies to the snailfish number. If any pair is nested inside 4 pairs, the leftmost such pair explodes. If any regular number is 10 or greater, the leftmost such regular number splits. So let's do another test. Imagine that. Here. Add explode. We'll grab this. Put it here. And I'm just going to start doing this, where I parse the answer as well. Because we're sure that the parser works now. So now we can start writing tests that make use of that parser instead of writing out all of the structs. This is an explode action. So we cargo test this, it should fail. This should be what? It's just explode, so I guess we have to write an explode function if we want to test it like this. So let's impulse snailfish. Right, so let me pull this use snailfish all the way up here. And let's say we have an impl add. Let's do impl snailfish. And this will have a function called reduce that takes a reference to self and returns a self. And this will be probably calling out to other functions. So like fn explode and fn split. Let's ignore this return value for now. Let's focus on explode maybe, where we get a reference to self. So we need to go 1, 2, 3, 4. Thus it explodes. So is there an easy way to do a depth first search of these pairs while keeping the original parent value around? So actually we're only operating on the ends, right? The very ends. Because we never operate on anything that is not at the end of the search. Actually, this operates on something that is not the end of a search. Seven, 3 inside of 1, 2, 3 goes to the next branch and adds 3 to the 6 and adds 7 to the 1. That's an interesting skip. I'm trying to figure out how to iterate over these. Like this first one can just be probably a for loop, right? So like self dot what? We didn't implement iter for this. Tip, implement this in chunks. I tried to do everything at once and regretted it. Fair. We need to do a recursive function here. Then. So fn step. Takes a self and a level. What we do here is when we reduce, we call step and self with a 0. Does it need to be like mutable or something? What's wrong with... Oh, yeah. So we get self and we match on self. And then we if it's a number, we do nothing? No. If it's, yeah, if it's a number, we'll come back to that. I don't know that we'll ever reach a number, actually reach. For a fish, we have A and B. So let's call reduce down here, I think. Expected enum snailfish found unit. Yes, that is expected at the moment. Let's return self for now. What am I messing up here? Expected enum snailfish. We could also make this mute. I think we're going to have to do that anyway, right? In which case we wouldn't return anything. In which case we would pass in a mutable reference in the test. Test still failing as expected. So we're into our reduce function. We're at step 0. If we have a fish and that fish, can we match on these? If we have number, this is going to need to be box number, right? Here's my question. Can we match on box here, actually? I don't know that we can. I want to. Rust, match box. Need a dereference, but I want to do this in the match, so maybe we'll just enable box patterns. Virgo plus nightly test. Need the experimental to match on box, I think. Box is a smart pointer, so dereference number. Oh, you think we could just do that instead? That's a good point. Get it? Point. That doesn't seem like it works. Seems like that's a syntax error. I think we do need box here. Fish. Yeah, because we're in a match pattern. So like we could dereference the like this. But I don't think we can do that to the constructor. We would have to do, because what I'm trying to do is I'm trying to match on the number. I'm not trying to match on the variable name that the box contains. Because I want to write more matches outside of this. Okay, so match self, box number. If we have numbers, then what do we do with them? We need to determine if they explode. So maybe we do the detection. This is going to be super awkward, right? We're going to have to propagate these values all the way back up from this function. If level is 4, then debug. Otherwise we do nothing, maybe. We're returning unit from everything, so this will still fail, and we should get 8, 9. Or is level 3 here? We should start at 1 instead of 0. We don't recurse, actually. We're not recursing yet. So for fish, box A, box B. These are going to be... How do we recombine this up? Let's do this. Let's do if box A is a fish. Then we have to handle A and B. If this is fish. I'm just trying to simplify this in my head. So if we have a fish, we need to continue calling step on it, right? Probably don't have a mutable reference, do we? Step actually isn't mutable. Okay. A is just the tuple for the subsequent A and B. So we need to do A.0.step here. A.1.step. Does that make more sense? Panicked it, not yet implemented. Where's our to-do? At 42? Here we go. I'll just debug num. One, 3. We don't hit 2, 4, which is interesting. So we should end up with a calls to what? Snailfish, 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 number, number. So what? These are stepping. These need to step. These need to step. This is kind of ridiculous, right? I'm happily writing this the wrong way. Number, box, box. So we get to num. And what do we do? So we are doing this semi-correctly. Let's see. So what we should get out of this, right, is we have this fish at the root. That contains a fish and a number. So we have a fish at the root that contains a fish and a right-hand side number. So fish number. We'll say this is number fish. This is fish, fish. And that's the number, and this is number, number. So with that, we get fish number. And then we step left. And we step right. So this will be left. Which gives us fish number again. So this would be... I feel like we skipped something here. Why are we immediately heading to 2? I guess because... Is this parsing weirdly? 1, 2, 3, 4, 5. 5 fish, right? 1, 2, 3, 4, 5 fish. And then 9, 8. So 9, 8, fish 1, fish 2, fish 3, fish 4, right? That's what it should be. 9, 8, fish 1, fish 2, fish 3, fish 4. And then wrapper fish. So we're dealing with 1, 3, 8, 9. I guess 2 and 4 come in. Why do 2 and 4 come in differently? It should be the same, right? Right, like we should get down to number for both of them. I guess this is both, right? So let's just not check that yet. That's 9, 8, as expected. That's fish. This is fish. This is fish A and fish B. We've got debugs on everything. So why aren't we getting 2 and 4? I need to get rid of this other thing that's flashing on my screen over here. Self step gives us the root fish. The root fish is fish number, right? Let's get rid of the fish debug wherever I have that. And let's do debug fish. Number, num, this goes here, num, cargo test. Okay, so what we end up with now is fish number for 4, which is the outside number, right? Yes. So we should get fish 4, at which point we're inside of this fish. Then we should get fish 3. Which is 2. Let's do print line here, because that'll be easier to read. Now I'm mumbling to myself. I'm sure that's useful for stream. Print line. Print line. Debug. Okay, so fish number 4, fish number 2. Why do we go to 2 and not 3? Is, I guess, my question. Because we should go down 1 level, right? Self. Fish number. Oh, because I go left before I go right. So we get the fish, that is the next one, and then we go down a level and we check left or right. Is there a way to tell cargo that this should always run nightly? Yes, I believe there is. I believe that's I think it's the rust up file. I don't use it ever. Cargo always run nightly. But if you want to yeah, Rust toolchain should be able to do it. Because Rust toolchain defines, and the documentation for what Rust toolchain is supposed to be isn't particularly amazing, if I remember correctly. Rust tool, but you can specify things like nightly and nightly on a specific date and stuff like that in the Rust toolchain file. I use that sometimes for Netlify functions so that it uses the same version of Rust, especially if I'm doing anything nightly. But I forget the syntax for it always, so I copy and paste it from my other projects. Okay, so we have a fish number. Right, top level fish, drop one down. We have a fish on the left and a number on the right. I happen to be printing that here. But what actually happens next is we drop into the fish. So maybe we just do this instead so I don't get too confused. Maybe I do numbers. And then we see 9813. You meant something akin to an MVMRC. That is the Rust toolchain file, Nikki. MVMRC and Rust toolchain kind of do the same thing. Am I digging too deep into these? Is that what's happening here? No, I'm matching on number. So actually what I need to be doing is print line yeah, exactly what I'm doing here, but it should be here instead. So really, do we need to match on any of these? Maybe not, but I think we need to halt them in different places. So that's why I am pulling this out. So now we get 9, 8, 1, 2, 3, 4, which is the pattern, right? 9, 8, 1, 2, 3, 4. Okay, that makes sense. Everything was fine. I was just debugging in a weird order because the order matters. Okay, so I think the only time we can detect if something should be explodable is in here, right? I think this starts at 1. This is, by the way, me writing Rust when I am basically so fuzzy that I need to lean on Rust to tell me everything. Level 2 is the wrong level, right? Self.step. And we go all the way down until we hit number. And number should be like 4 levels deep. So where am I not doing this? I'm doing level +1 everywhere. We do number fish. We do this. We do +1. I think we hit number fish for all of these. So let's do this. Print line. Num fish. Num fush. Num fush. So we should hit 4 of these before we hit number, right? No, wrong one. It's this one. We only hit it twice. Am I destructuring too much? Is that the question? So we step on a fish. And I think I am. I think I'm destructuring this too much here, right? So let's take this out and let's do I think I'm doing extra destructures basically in an attempt to solve the problem that we're going to come up against later. But I think I'm just going to do this for a second so that I can get through. And now we have number level 4. 1, 2, 3, 4. Yes, you are all correct. Level greater than 3, greater than equal to 4. That was not the problem we had before. The problem we had before was that we were skipping levels in the iteration. So basically, if you look at what I was doing here, when we step, we pass in the next fish. But what I was doing is destructuring that fish and destructuring the interior fish and then working with the interior fishes. So I was going too far, basically, in the destructuring. So this needs to return something. I think maybe it returns operation, where operation is explode or reduce or split. Split is the one. Split. This is sum operation because we might not have to do anything. So for number, it will be none, right? Why is that complaining? Oh, because I'm not returning that and everywhere, right? Oh, because it's some and not. Dude, I'm telling you, my brain is just not doing it today. That's the neat thing about recursion. You only need to handle one level. Yeah, that's the neat thing about recursion. What am I doing here? Level greater than or equal to 4, debug. Then we sum operation explode, right? Otherwise, none for now. This is going to be... This is going to be weird, right? Fishes. Just do none here for a second. We do have to work this information all the way back up. So if we do this, we do option operation. Maybe I should have named that something else. Okay, so let's get rid of the debug there. Let's get rid of this debug. Let's get rid of this debug. And now we have that we should explode here, right? We always do depth first, so we always hit the first one first. When we need to explode, that means that we'll get explode back from one of these. I think explode... So what do? We explode the bottom one, so we remove it entirely, basically. So this is going to be a snailfish with number. We're going to get back from this that we have to explode. We are going to look at the level above it. And I think we need to keep these numbers as we go up. So I think what we need to do is explode needs to be AB. Right? Because we need to carry this information back up. Somehow, anyway. Are they not U sizes? Or are they U32s? They're U32s. That's fine. We do need to reference them because we're basically copying them into this explode instead of giving them references. Which means that fishes will get an operation, right? And this will also get an operation, but we only really need to care about the first one for the second. So match operation sum operation explode AB. Let's do for none, we do nothing. If we have to explode, sum operation split, then we to do split explode, which means that at fishes 0, if that was supposed to explode, we have to remove it, right? So what do we do here? If we're at fishes 0, which means we have snailfish and then the other arm is 1. Then we have explode 9-8. And we have to remove that snailfish and replace it with a number. I'm going to, I think, the thing that really gets me is this right here, where we have to go up multiple levels to add to it. So we're here, we have to explode, we have the numbers. Fishes.0 is the thing that had to explode. So fishes.0 should no longer exist. And from this, we return fish box new. We're not reducing here, though. We're just doing a for loop. So fishes.0 equals number. We'll just call it 0 for a second. And then fishes.1 I'm just going to leave for a second. And then we return none from this because there's nothing we need to do, right? Or we break. We aren't for looping though. We are recursing, and we can't break out of the recursion. So we need a stop here. Operation is yeah, I cannot be written to it. But why isn't Rust Analyzer telling me that? Why is Rust Analyzer complaining about fishes? Yada yada. Cannot move out of self.0, which is behind a shared reference. Self.0 is mute self. Can we recurse like this on a mute? $47. I feel like I approached this completely wrong, and that's why it's not working. I feel like I should have taken a different approach. Data moved here. Move occurs because fishes has type box snailfish, which does not implement copy. Yeah, I mean, that makes sense. Cannot move out of self.0. Self.0 is this. Cannot move out of a mutable reference. Ugh. Mute fishes. Rust compiler to the rescue. What am I doing here? My brain is so fuzzy today. So horrible. Okay, so we've got snailfish, right? We've got snailfish. Snailfish has nested snailfish. We iterate through them. We need to mutate one of the snailfish. I am inclined to return a new snailfish instead and reconstruct the snailfish using the recursion. And I think that's what I'm going to do instead of trying to do some weird mutation thing. This is going to return we're not going to do this mutation. Take a shared reference to self.stat. We probably won't make that mutable. This is probably going to be a tuple. This is probably going to be a tuple with snailfish operation. The only other thing I could think of is if we return the actual snailfish we need to operate on. But again, I'm still bugged by the fact that we have to not only recurse out of this, but recurse all the way potentially back to the top to modify this. right? Like, nine eight has to come back up one, add to the snailfish on the right, which is fine. But in this case, for example, we have to add 8 to the snailfish on the left. And then 0 to 9? Right, like in this example right here, we have to take 3, 2, add 3 to 4, which is right next to it, but bring 2 all the way up out of this root and add it to like the top level right hand side. That's the really annoying part. So really I need to map over everything in this tree and keep the count. But if I map over it, we need to keep state around, right? I feel like they wanted me to store this in a vec, right? Like I feel like they just wanted me to do this in a vec all the way down, and it's written so that you get the index of where it is, and then you get the index of something else, and then you just mutate both spots. Will it help to give all tree members numbers? If we gave them all numbers, we would have to maintain those numbers over time. Right? Like, if we reduce, if we explode, I think that's okay, because we just remove the one. But if we split, like, the split is easier, actually. We probably should have started with split instead of explode. Because this is just replacing the one node. But if we replace something, we still need mutation, which is super annoying. Yeah, I think that the solution to this that they want me to use is just a vec of vecs. Because if it's a vec of vecs, you can just index into anything. You can figure out exactly where you are, return that value, and then go back and mutate it. And mutation at that point is easy. Which is really disappointing. Let's see. Let's see, traverse. I don't know the name of the thing that I need to accomplish this in Rust. If we just return... If we return the snailfish, so this is number num none, because there's no operation to handle, right? And we just copy this. Then for number, we do the check. If the check happens, then we return nothing, I suppose, right? So none and the explode operation. Which means that this is box new number A, box new number B, and none, right? Because there's no operation to handle. So this is sum. Snailfish operation. If we return the lower part of the tree for this, we can build it up from the bottom. None, some fish, none. Why is this yelling at me? Because it's not, doesn't match all the others, or expected tuple found option. This is supposed to be a tuple of snailfish operation. Snailfish operation, tuple. Snailfish. This needs to be option. And this needs to be like this. And this is some number. If we get down that low, right? And this is some fish. This needs to be copied. This needs to be copied. Fish. There's a problem with fish on 60. This needs to be a tuple. So we reconstruct a fish from the numbers. Otherwise, we take that and we say we're going to explode it. This way we get here and we have an operation which is fish and some operation, right? And this is going to be fish and some operation, and this is going to be, I don't know, fish and none. The numbers only have to be unique. That can be done a static variable. That's what I did, keep everything in a vec and mutate it when an explosion split happens. Yeah, that feels, you know what's really unfortunate is it feels like that's what they want you to do. So that's how they wrote the problem. So that's how the logic works. So we don't set fishes 1 here. We If we have to explode, then we have subfish, new fish. We'll call this new fish. Then when we return from match, why is match complaining though? Is it because I'm not matching everything? Expected tuple found enum option. Okay, let me do to do here to just blank out that error for a second. And we have fishes is a shared reference, so the data it refers to cannot be written. That makes total sense. We don't need to write it anymore. So what we have here is fishes.0 has an executable operation, right? Same here. This is an executable operation. If we don't have an operation, if we're operation stop, then we do nothing and we just return fish, right? Because the return type here is new fish. We just return whatever new fish gave us. Expected unit found tuple. Why are we expecting unit here? Because we're returning unit from the first one. So we have a new fish, right? And we have the nums. The new fish might be none. So we have to match on new fish now. If we have a new fish, well, if we don't have a new fish, then we don't have a new fish. That means we're exploding, which means that we have the left-hand side to deal with. We're exploding. We just returned from the snailfish. Thus, we might have a number on the right-hand side or the left-hand side. In this case, the right-hand side. So the explode operation actually needs to be something else here. It needs to be some U32 and some U32, right? Because our option, because these will evaluate at different times, which is super annoying. So every time here, there's going to be some this value and some this value. And the fish will return from that all okay. And this is when we are operating on higher level fishes. So if we're exploding, if we have a new fish, I guess it doesn't matter if we have a new fish here, does it? Match fishes dot one, right? If fishes one is a number, then we have to return the whole thing, but it's going to be num plus. Then we have to do a whole thing here. Jeez. Let new op equals. Let's see, match fishes dot one. And tracking the parent, then we can go one step back. I read a tree structure works too, and you can get one by parsing a line as JSON. Yeah, I mean, you could say that. Well, that's the thing, right? If you operate on this as JSON and you use indexes, then you can index into and mutate it. They really want you to do that hold a structure and mutate it approach. And I'm not doing that here. And this pull the data back out and bring it to the top is really, really annoying. Match fishes.one number num let new op equals. So the options really are, I can either do that and just use indexes and get it over with, or we can continue. Match fishes.one. Actually, if I don't have this done in the next half hour, I'm going to get some food, because I think what really is happening here is that my brain, for some reason, is just not working with the booster shot, and everything's super fuzzy. Match fishes.one number num let new op equals. What was I doing here? We explode. We have to check the right hand side here because we have a fish on the right. Number num fishes.one. Okay, if the right hand fish is a number, then we do if let some right or some op num equals right. Let me do op num plus num, else num, let new num equals this. Do that. Of course, it reformats outside of the window. There we go. So we have the new number, and then we need fishes.one to be number new num, which is part of the tree we're building up. So New fish. New fish is theoretically empty. So 9, 8, right? We pull out. And then fishes.1 is this one. And then we have an empty spot, basically, that we need to fill. And I think we fill it with the number on the left. For now. So what we end up with is fish, tuple, number. I'm just going to unwrap left for a second while I get my brain around it. And then that's going to be operation explode left. None. Some operation explode. This is a tuple. The fish ends here. Yikes. This is ugly, is what this is. Okay, so we have number here. This needs to be boxed. The other one needs to be boxed. So other than this left unwrap, which we need to potentially keep around for a while, right? I guess, is there a case where we bring it all the way up on the left? Not if we have an empty right, right? Like, if we add to the number on the right, then we don't have a number on the left. Right? And if we add to the number on the left, then we have no number on the right. Unless there is no middle. We cannot have a middle. Okay, so this is 0. Always. Right? I think. Like if we have 9 and 8 here, they're at the bottom. They only have a right-hand side. They cannot have a left. So there's 0. The problem is when we get to here. Here. 6, 5, 4, 3, 2 inside. And then a 1 way the fuck over here for no reason. Becomes 6, 5, 7, 0. And then we add 2 to the 3. So because there's no number there, we have to force this into being a 0, but we still propagate the left up to potentially add it to something. Yikes. What is the problem on line 82? Oh, right, that is snailfish option operation. which is not going to be a thing, I don't think. Is it? I guess it could be, theoretically. But because we already have an explode, we don't have one. We don't have an operation here. Expected box found snailfish? I guess. Okay, so on 82, expected box found tuple because this is now a snailfish. Right, we've returned snailfish up. Which means this is actually some and not a box. Some number. And I got this wrong, actually. So this is some fish. Expected 1 field, found 2. Perfect. Just what I wanted to see. This is a tuple. Oh, fishes.1 is box. I'm blanking. My brain is hurting. So this is actually box. Right? And this doesn't have an operation. Because we're still iterating through. And those parens aren't necessary. So that's fine. Allegedly, I can remove these. So down here, match arms have incompatible return types, which I think makes sense. 114, this is the match for the total result of applying the fish's 0 operation. If the operation is split stop or none, this just propagates stop, I think. Extracted snailfish option found. So let's just unwrap this. Because if we're stopping, then we did something and we have fish. Here will be fish.unwrap. I'm just gonna wait for those to actually bug out before I do anything about them. This is none. $121. Okay, 121. If we have a result here, which is snailfish option operation, right? new fish, op, match op. If none, then we have to do the same thing here. If some, just get that out of the way. If some, then we return this whole value, right? Oof. Okay, so I think we do the return from in here. If we do, let's keep the to do over there for a second. If we do result 2, right? If this, then we return that. New fish sum O, which is, what is our return type? Jesus, this function is getting so big. Option snailfish option operation. So we just propagate that up. Do we contain the other fish? I think we contain the other fish, right? This needs to be a single element. Is new fish a snailfish? Is that the problem? New fish is a snailfish. We don't need to unwrap it. We're just going to clone this up. These are both going to have to be box new because they're inside of a fish now. I don't think we implemented clone for snail, so we do need to go grab it. Actually, can we just move it? No, we cannot. We cannot move it. So we do need to clone it. I think it's already a box, so maybe it will just work. And holy, we're on to the next thing to do here. This returns. Hopefully that doesn't light up in red. It did. Oh no. Mismatch types. Expected tuple found unit from 133. Woof. Okay. That was an adventure, is what that was. How do I get this big enough to show these? Fish, fish, fish. Fish number 0, number 9, number 8. 0, 9, 2, 3, 4. So the left fish seems right for the test. Actually, it's not. So the input fish is the one we need to modify. Input fish dot reduce. This is the wrong way to call this now because we're not actually mutating it. We are going to return the snailfish out of it. This is not going to be mutable. We have shared reference to self. Expected snailfish found tuple. Yes, because step returns option snailfish option operation, which if we are at the root level up here, fish, and then we don't care about the operation anymore because it should be done. If it's not done, then we messed up big time. We should be able to unwrap that and send it back. And then here, we reduce. Okay, so now we have 0, 4, 4. Is that what we have? Do we have 0, 4, 4 for this number? Wow, that is wrong. That is very wrong. That's not good. It's actually really bad, is what that is. There are so many people following me right now. Okay, so we are deep in the shit. To put it pretty frankly. The way that I've written this is building back up a thing. We do get 0 for one of the numbers, which is great. We are not getting the correct pulling out of it. I think we are returning number 4 way too much. So the first number there should be number 1, which makes me feel like this is, that's the parser. Let's get rid of the parser for a second. Get rid of all of this stuff so I can just look at what we're supposed to be doing. Get rid of these. Open this giant function that I wrote back up. We've got reduce, right? So if we hit something that is level greater than or equal to 4, we need to explode. We explode with the values that we return, and then we return none for the fish, because none for the fish, which I bet you we can match on maybe. Yeah. If we return none for the fish, that means we removed it and we don't want it there, right? Otherwise, we just return the fish again. We start building it up from the bottom. The fish here is where we get that result. So fish is 0.step level +1 is where we get the 9, 8 as an operation result. So op here is an explode, or is an optional explode, because we might not have one, right? Here, we might not have one. So we need to handle both of those. So we match for new fish and for operation explode. If we have an operation explode, we may or may not have a fish. But we do need to be exploding. So we match on the other fish, basically, right? There's the fish that we did the operation on to see if it should explode. And then we have fishes.1. In this case, fishes.1 is the number 1, right? So if we match on number 1, then we let the new number, which should be eight plus 1. So if we do this, then we should get a debug op num num. This should debug out 8 plus 1, 9. If we do not get a 9, then we have a bigger problem. Op num 8, num 1, 9. Okay, so we're here. This works. Down to here, this works. So the new number is this if let sum, right? And then we have to return something. When we return a fish that has the number 0 in the left-hand side, the number 9 in the right-hand side, and a operation for explode that needs to stick around. So we get that back out, right? Apparently we never hit fish here, which we'll probably hit at some point. So that returns out of fish, right? So we get new fish and op. New fish here then should be a fish of 0, 9. So if we debug new fish, then at some point we should get 0, 9 as a fish. If I don't do move errors in my debugging. So we have 0, 9 here. If we did that, then we've already processed fishes 1, right? Because we have 0, 9. We've already processed fishes 1. Where's fishes 1? Fishes. So we've already matched on fishes 1 in here, which means that unless this just needs to be new fish, I think. What's the type there? Oh, right. Some new fish. Right? So match op, some new fish, some operation. We still need to explode. Right, we still need to... I'm keeping the left-hand side, aren't I? 9, 8. Yes, I keep the left-hand side around forever in this case. And then we just drop it. So, new fish, 0, 9. With the explode operation that we are carrying through. In this specific case, then, the fish above it should be in fishes, right? Because it will have... Actually, it should be in fish here. So, if we are not greater than or equal to... Or that's not fish. That's not the right one. That's not fish number. That's number. So we should be in fishes no matter what here, right? And if what we have is a snailfish and a snailfish, and our operation then the thing that we just got back is 0, 9 and explode. Should we change this to a partial explode? Because I think we're just assuming here. So explode right. This matches on fishes 1. If there is a number to the right, then we deal with it. If not, then we return num, which is just the number, right? And if not, then this becomes a different return type, right? So this would go here. This is let new num equals this. New num is now unit. So here we need basically this, but we don't do anything. So we're just returning the same value, right? So what do we do here? We don't do box new number 0. We do box new box num. And then this fish is fishes.0, right? This is new fish. That's the wrong one though. This and then that, and then this is new fish. And probably .clone, but let's see. These are the return types. And expected box found option. So I think in this case, we will always have one, and we always need one to be boxed. Our test just passed. Did it? Holy moly. Unfortunately, I think Rust Analyzer broke, but our test passed. This is a lot. Okay, so hilariously, after all of that, we did get it to work. And the add explode now passes. So 981234 gives us 09234 when we reduce. Now, the things we haven't implemented are the left-hand side explode, as well as split. So this, I think, is the left-hand side explode, right? So let's set up a second test, and let's make sure that we copy and paste this logic around correctly. Because it's just going to be, a little bit of an annoying copy paste job. I'm not going to abstract it. I'm just going to deal with it. So the input fish is this fish. The output fish is this fish. And this fails because we haven't implemented, which is exactly what we expected. Because basically what happens here is that this is an absolutely massive function. So I'm going to take the type signatures away for a second. This match on self. When we get to fish, we do this operation on the first fish. Right? We do all of this. We do explode, we do the match, we do... we don't do what happens if it's a fish. Where's the error that we're actually getting? Just to make sure that I'm in the right spot. 137. So all the way down to here is where we get. If there's no op on that new fish, we need to do the same thing we just did for the other side. So I think what I'm going to do here, even though it kind of feels painful, is same as above for right-hand side. So this is going to be fishes.1. This is going to be flipped in terms of the tuple. Actually, that's not going to be flipped in terms of the tuple. The thing that is going to be flipped in terms of the tuple, we don't need to match on fishes 1, I guess. Do we? We'll match on fishes 0. If let sum debug new num, the fish here is the thing that we need to flip. So now this goes here. And this goes here. And all of that works, except for the fact that we're not returning the right stuff. So where's our opening here? It's here. And we need to return the new fish and the operation, which is this. So this is what we need to return, which means that this needs to not be a semicolon. And new fish is not what we need here. Okay, so we're left with 2 errors. Expected enum option found snailfish. So this is a sum fish. And this is a sum fish. And we cargo test. And we cross our fingers. And it doesn't work. 76560. So close. 765, and this comes out as 6, but it's 4 plus 3. So let's check our debugs here. Op num 2, num 4. Why is num 4? That's the big question. Why is num 4? Is it because I didn't set up the test correctly? Or is it because 3270? Okay, 5, 6, 7, 6, 5, 4, and 3, 2. I'm adding the right-hand side number is what's happening. So where is our... This needs to be left. And when we return this, this is going to be none now. And this is going to be right. And that will pass the test. Ta-da! We don't have skip. But we do have this amazingly awful breaking my formatting level function that we wrote. Oh man, that is a lot. Okay. Now what? Now we have all of these things. We should probably pull in one of these more complicated ones and make sure that these tests pass. I hope they pass, because it would be really awful, really, really awful if they didn't. Okay, so let's do this one. And that is, what's the one for this? That's just becomes whatever. Both. And this one becomes this one. And we'll copy and paste this again for another test. And we'll write this one becomes this one. And then we have one more. Is that the same one that we just saw? No, it's not. Okay. So there's a bunch of tests. This is not unaffected. What is the description on this one? This one is... There's no description on it. Perfect. Wonderful. And I cross my fingers and it fails for all of them. Okay, so let's see. It's 1 p.m. I think this is just going to be a lot of work through at this point. I chose to go the verbose, ugly, awful way instead of the way that the problem wanted us to do it with, like, arrays and mutation or whatever. So I had to write all this logic to handle all of this. I noticed that my Rust Analyzer formatting broke at some point during the stream, right? Like if I hit enter here, it doesn't do anything anymore. So I need to restart VS Code or something to fix that. I think I'm going to finish the rest of the problem off stream. I'll get it done and I'll explain it tomorrow morning. And I'll catch y'all tomorrow. I think that's what I'm going to do. I think I'm going to take a nap. I'm going to sleep off the booster. And I'm going to come back again tomorrow and stream. Because my brain is super fuzzy.